The temperature warning light had been on for 10 minutes before Gene Vantrease finally shut the combine down at the end of the row, and by then the whole cab smelled faintly of hot coolant. 3 mechanics had already been out to look at this machine over the past 2 weeks, and now a 4th estimate sat folded on the hood of the service truck, this one for a new radiator and cooling package, running close to $12,000 once labor and downtime were added in. Gene stood with his arms crossed, staring at the gauge cluster like it owed him an explanation. Beside the machine, a young man in a dusty seed corn cap crouched near the front of the cooling stack, running his hand along the outer screen where it was still warm to the touch. His name was Corey Lattimore, 20 years old, and for the past 3 harvests he'd been the one fueling equipment, greasing zerks, and blowing chaff off screens before anybody else showed up in the morning. "Can I ask something?" Corey said, standing up. Gene and Hollis Renner, the 3rd mechanic who'd been called out that week, both turned toward him. "If the radiator can't cool it, why did it run 40 miles down the highway yesterday without ever getting hot?" Nobody answered right away. Hollis frowned, not offended, just turning the question over the way you turn over a part you don't quite trust yet. "Road isn't the same as a full head of corn going through it," Hollis finally said. "Different load entirely." Corey nodded and didn't push it. He wasn't there to argue. Not yet. The 3 of them stood there a moment longer, the machine ticking as it cooled, and the story of how they'd gotten to a $12,000 radiator estimate had started almost 3 weeks earlier. On the first truly hot afternoon of harvest, Vantrease Farms ran a little over 2,300 acres in central Iowa, corn and soybeans in rotation, and the whole operation leaned on one combine. A big self-propelled machine pushing 15 years old, but still capable, still valuable, still the only thing standing between a narrow harvest window and a field full of grain sitting past its moisture. The combine had run clean through the first few days of the season, soybeans mostly, light dusty work that never pushed the engine or the cooling system especially hard. Then the crew moved into corn, thicker stands, heavier stalks, more material moving through the head and up through the machine. And on the second afternoon, in a dense 40-acre block along the county road, the temperature gauge started climbing. It happened gradually, the needle drifting up past normal operating range about 25 minutes into a steady run, no warning beforehand, engine RPM holding rock steady the whole time. The operator, a longtime hired hand named Walt Riedenauer, backed off the header speed, then finally shut down and let it idle, watching the needle fall back toward normal within a few minutes. He checked the obvious things himself before calling anybody. Coolant level was full, no visible leaks under the machine. The radiator screen looked reasonably clean from where he stood, some chaff built up along the lower edge, which he brushed off with his glove. He started it back up, ran another 20 minutes, and the temperature crept up again, right on schedule. Gene got the call that evening and had a mechanic out the next morning. The first mechanic to look at it was Pete Vachel, an independent who'd serviced Vantrease equipment for years and knew the machine's history about as well as anybody. Pete started where any good technician starts, with the simple things. He pressure tested the cooling system for leaks and found none. He checked the coolant condition, pulled a sample, and it tested fine, no oil contamination, no sign of a blown head gasket, or anything more serious hiding underneath the obvious symptom. He inspected the thermostat, pulled it, and found it opening a little sluggish, not fully stuck, but not snapping open at spec temperature the way a healthy one should. He checked the radiator cap too, and the spring pressure had dropped below where it should hold, letting the system run at a slightly lower boiling point than it was designed for under load. Both were reasonable finds. A tired thermostat and a weak cap wouldn't cause a 15-year-old machine to overheat on their own most of the time, but combined with a hard-working engine in heavy corn, they could easily tip a marginal cooling system over the edge. Pete replaced both, flushed the system fresh, and sent the combine back to work. For about a day and a half, it ran fine. Gene started to relax. Then the temperature climbed again in another block of heavy corn, worse than before. It happened on a Thursday afternoon, in a 40-acre field that ran along a low rise where the corn stood thicker and drier than almost anywhere else on the farm. Walt had the header down, and the machine humming along steadily when the gauge started its climb, faster this time, cresting into the warning range in under 20 minutes instead of the 25 to 40 it had taken before. He shut down, let it idle, watched the temperature fall, and tried again. Same result, same field, same steady climb. He radioed Gene from the cab, and Gene drove out himself to see it firsthand. Standing at the edge of the rows with his hands on his hips while Walt explained what had happened. New thermostat, new cap, and it's still doing this, Gene said, more to himself than to Walt. Overnight, a weather system pushed through the region with just enough rain to remind everyone how little margin they actually had left. It wasn't a hard rain, barely a third of an inch, but it was enough to push field entry back a full day while things dried out, a day Gene couldn't easily get back with the forecast showing another, larger system trailing behind it by the end of the following week. That was the afternoon he called Roy. Gene called a second mechanic, a dealership tech named Roy Delgado who specialized in combine cooling systems specifically and had a reputation for being thorough. Roy came at it from a different angle. He suspected the fan drive first, a common wear point on machines this age, since a fan running even slightly under its rated speed could starve the whole cooling stack of the airflow it needed under heavy load, even with a perfectly good radiator core underneath. He checked fan RPM against engine RPM across the operating range and found it tracking correctly, no slip, no worn belt losing tension under load. That ruled out the drive itself, but Roy didn't stop there. He pulled the cooling stack apart from the outside, the layered arrangement of radiator, charge air cooler, and hydraulic oil cooler stacked one behind another, the way most modern combines built airflow through a single fan pulling air through all three at once. He found the outer sections dirtier than they looked from a quick glance, packed with fine dust between the fins in a way that wouldn't show from a distance, but would absolutely restrict flow once you got close enough to feel for it. He cleaned the entire stack thoroughly, using compressed air and a low-pressure rinse to work dust out from between the fin passages without bending anything, then reassembled it and ran the machine hard on the yard for over an hour. Temperature held steady the whole time. That ought to do it, Roy told Gene. Stack was choked worse than it looked. Give it a real test in the field tomorrow. Gene allowed himself a little relief that evening, mentioning to his wife over supper that it looked like the worst of it might be behind them, and that maybe they'd get through the rest of harvest without any more surprises. The next afternoon, back in heavy corn, it ran clean for nearly 40 minutes before the temperature started its familiar climb, better than before. Still not solved. That was when Gene brought in Hollis Renner, an older mechanic with a reputation for being the guy you called when two other people had already struck out. Hollis looked over what Pete and Roy had already done, agreed both had found real problems worth fixing, and moved his attention toward the radiator core itself. He ran a flow test, checking coolant volume, moving through the radiator against what the pump should be delivering at that engine speed, and got a number that came back a little lower than the manufacturer's spec called for. He also checked the water pump itself, verifying it wasn't cavitating or slipping on its drive, and confirmed the impeller was turning at the correct speed for the engine RPM it was seeing. That ruled out the pump as an independent cause, but it didn't change the flow number he'd already measured downstream at the radiator. Core's old, Hollis said, tapping the radiator housing. 15 years of thermal cycling, some internal scaling even with clean coolant, tube walls losing efficiency a little at a time. It's not dramatically bad on paper. But combined radiators of this age start losing just enough capacity that they can't keep up once you load them hard in heavy crop. I think you're looking at a new radiator, maybe the whole cooling package while you're in there. That was the estimate Gene was holding when Corey asked his question. $12,000 for a new radiator, hoses, and enough labor to pull and reinstall the entire cooling stack. Gene didn't think Hollis was wrong to suggest it. 3 mechanics had each found something real: a sluggish thermostat, a weak cap, a genuinely dirty stack, a radiator flowing under spec, and every fix had helped a little without solving the whole problem. But rain was in the forecast. For the following week, corn moisture was sitting right where it needed to be, and Gene was running out of both patience and time. His farm foreman, a stocky, no-nonsense man named Buck Ostrander, who'd worked the operation almost as long as Gene had owned it, wasn't shy about saying what he thought Gene should do. Order the radiator, Buck told him flatly, standing in the shop doorway with his arms crossed. We've burned 2 weeks on thermostats and fan drives and stack cleanings, and the thing's still overheating. Hollis found the number on paper. Radiators flowing under spec. That's about as clean an answer as you're going to get this deep into harvest. Gene didn't disagree with the logic. He just hated the price tag, and he hated more the idea of losing another 4 or 5 days waiting on a part to ship in, while corn stood in the field getting drier and closer to a rain that could flatten a week's worth of yield overnight. Custom harvesters in the area were already booked solid through the rest of the season, and the one outfit Gene called about renting a comparable machine quoted him a daily rate that would have eaten the Radiator estimate inside of 2 weeks anyway. Corey had been on the crew through all 3 of those visits, mostly just handing tools and holding shop lights, but he'd started noticing something that none of the 3 mechanics had specifically been asked to look at. The combine ran fine on the road every time, 40 miles at a stretch some days, moving between fields, engine turning close to the same RPM it held during a steady harvest pass, and the temperature gauge never so much as twitched out of normal range. It ran fine at light load, too, idling in the yard, running the unloading auger, sitting parked with the engine up for an hour while somebody serviced something else on it. It only climbed once it had been chewing through heavy corn for 20 to 45 minutes at a stretch, and it climbed faster and higher the thicker and drier the stand was. Corey mentioned it to Pete, back during that first visit, almost as an afterthought. It never does this on the road. Road's a different load profile, Pete said. Steady speed, no header running, no threshing load pulling extra horsepower. Makes sense it'd run cooler. It was a reasonable answer, and Corey didn't argue with it. He just wrote it down anyway, in the small notebook he'd taken to carrying that season for the diesel technology classes he was taking 2 nights a week at the community college in town. Runs cool on road at similar RPM. Only climbs in heavy corn after 20 to 40 min, getting worse with drier, thicker stands. He also started paying attention to soybeans versus corn, once the crew rotated back into a soybean block for a couple of days, to give the corn ahead of them a chance to dry down a little more before cutting. The combine ran the soybean ground for hours at a stretch without so much as a flicker on the temperature gauge, even in full afternoon heat. Soybeans threw far less chaff and dust than corn did. Thinner material moving through the head with none of the heavy stalk trash that corn kicked up behind the machine. That was one more data point pointing the same direction. Whatever was happening tracked with the volume of dust and chaff in the air around the machine, not simply with how hard the engine was working. The idea that this might be about more than simple engine load started forming a few days later, after Roy's cooling stack cleaning had bought them that better, but still incomplete 40 minutes. Corey noticed that the overheating seemed to track with something besides just time and RPM. It got worse specifically in the driest, thickest stands, the ones throwing the heaviest chaff and dust behind the machine, and it seemed almost tolerable, at least for longer stretches, in a thinner or slightly damper block of corn nearby. He mentioned this to Roy, who by then had earned Corey's trust as the one who'd actually found something real inside that stack. "Isn't just RPM and load, is it?" Corey said. "Seems worse the dustier it gets." Roy considered that for a second. Could just be that heavier crop makes the engine work harder, which makes more heat, which asks more of the cooling system generally. That'd track with dust too, since drier corn kicks up more of it. That explanation held together, and Corey didn't have anything solid enough yet to argue against it. But that night, reading ahead in his coursework about combine cooling systems specifically, something caught his eye that he hadn't thought about before. Modern combined cooling packages depended on a fan pulling air through a very specific path, in through a rotary screen or outer shield, through the stacked coolers behind it, and out the back or side of the machine. The whole system only worked as designed if that path stayed sealed, and the fan was actually pulling from the front, from clean outside air, instead of finding an easier route from somewhere else. If a seal or baffle around that stack failed, even partially, the fan could start pulling some of its air from the hot, dusty engine compartment instead of from outside, recirculating heat that was supposed to be rejected rather than dumping it clear of the machine. That would explain almost everything. The radiator screen would look clean from the front because the fan wasn't relying on it as much as it should. The problem would get worse the dirtier and drier the field got, because more chaff meant a thicker, hotter layer of recirculated debris-laden air building up wherever that seal had failed, and it would barely show up on the road at all. Where there was no chaff to speak of, and moving air around the machine helped mask a compromised airflow path that hadn't yet been asked to do its full job. He underlined that last part twice, his first real theory. Once he decided to test something, instead of just noting it, was the reversible fan itself. The combine used a fan that could periodically reverse to blow debris off the screen, and Corey wondered if it might not be cycling correctly. Spending too much time in reverse or not building full airflow when running forward, which would explain reduced cooling under sustained load without needing any hidden seal problem at all. He asked Pete if they could check it properly, and Pete, who by now had gotten used to the kid asking to verify things instead of just accepting an explanation, hooked up the diagnostic reader and watched the fan cycle through several reversal sequences. It behaved exactly as designed, reversing on schedule, building full rated airflow in forward operation, nothing unusual in the data at all. They also checked the temperature sensor itself against a calibrated reference thermometer, just to rule out a false reading entirely. It matched within a couple of degrees, well inside acceptable tolerance. Fan was fine. Sensor was accurate. That idea was dead. Corey crossed it out in his notebook, noted the time it had cost, and didn't let it discourage him. It told him something useful even in failing. Whatever was happening wasn't a fan speed problem and wasn't a sensor lying to them. The heat really was there, and the fan really was moving air. The question was where that air was actually coming from. He tried one more simple thing before moving on to anything more involved. He pulled the outer rotary screen a second time, even though Roy had already cleaned the stack behind it days earlier, thinking maybe fresh chaff had built back up quickly enough in the meantime to explain the renewed overheating on its own. The screen came off reasonably clean. Nothing like the packed mess Roy had described finding the first time. Whatever was happening now, it wasn't simply a matter of the front screen refouling that fast. That ruled out the easiest possible answer and left him looking for something less obvious. He started paying closer attention to the machine itself instead of just the gauge, walking around the cooling stack while it ran, trying to feel and see what the air was actually doing, rather than assuming it was doing what it was supposed to. For a couple of days before he tried anything more deliberate, he just watched. He noticed that dust settled differently around the lower edge of the shroud than it did anywhere else on the machine, a fine, packed film building up along one seam that never seemed to blow clear the way loose dust did everywhere else on the exterior. He noticed too that chaff sometimes drifted sideways into that same low gap during a pass, instead of blowing straight past the machine the way the bulk of it did behind the header. None of that was proof of anything by itself. But it was enough of a pattern that when he finally decided to test it properly, he already had a specific spot in mind, instead of guessing blindly at the whole machine. One afternoon, waiting on the combine to finish a pass, he tore a loose strip off an old shop towel and held it near different points around the cooling stack, while the engine idled up under load in the yard, just to watch how the airflow behaved at each spot. Held directly in front of the rotary screen, the strip pulled straight in, exactly as it should, clean and strong, showing the fan doing its job of drawing air through the front the way the design intended. Held down low, near a gap where the shroud met the side panel below the stack, the strip did something different. It didn't fly free in the ambient air the way it should have, if that area wasn't part of the airflow path at all. It got pulled sideways, toward the gap, disappearing into the shadow beneath the stack instead of blowing away in the open air. That told him the fan wasn't just pulling from the front screen. It was pulling from somewhere else too, somewhere it wasn't supposed to be pulling from at all. He got down on his hands and knees and shined a flashlight into that gap, and behind the visible edge of the shroud, tucked between the outer panel and the back side of the first cooling section, he could just make out a shadowed mat of packed chaff and dust, built up over what looked like more than one season, sitting in a space that should have been sealed shut. He didn't touch it. He just wrote down what he'd seen, sketched a rough diagram of where the gap was, and went to find Roy. "I think the fan's pulling air from somewhere it shouldn't be," Corey said, showing Roy the strip test and the flashlight photo he'd taken with his phone. Roy looked skeptical at first, the way anybody would after already having cleaned that stack thoroughly once already. "I went through that whole thing. Cleaned every fin I could reach." Buck had wandered over while they were talking, and he wasn't shy about weighing in either. "Gene's already decided to move forward on the radiator quote," Buck said. "I don't think we've got time to be chasing shop towel tricks 2 days before he's supposed to sign off on that order." "I'm not asking him to hold off forever," Corey said. "Just long enough to measure something properly. If I'm wrong, it costs an afternoon. If the radiator ships and is not the actual problem, it costs a lot more than an afternoon." Buck didn't look convinced, but he didn't stop them either, just shook his head and went back to whatever he'd been doing before, muttering something about kids and theories that Corey chose not to hear clearly. "You cleaned what's visible from the front," Corey said. "I think there's a gap lower down where a seal's supposed to be, and it's been packed with chaff a while, and air's coming through there instead of through the front the way it's supposed to. If it's coming through a gap, it's still coming from outside. Why would that overheat anything?" "Because it's not coming straight from outside," Corey said. "It's coming up from underneath past the engine, hot already before it even gets near the radiator. On the road, there's less of that chaff mat built up, because there's less material to pack in there in the first place, and the ambient airflow around the whole machine probably helps mask it some. In heavy corn, more chaff keeps feeding into that gap and building the problem up as you go, and the air getting pulled through it is hotter and dirtier the longer you run." Roy sat with that a moment, arms crossed, looking at the photo instead of at Corey, which by this point Corey had come to recognize as a good sign rather than a bad one. "Let's actually measure it before we start pulling panels," Roy finally said. "If you're right, air temperature right at that gap ought to be running noticeably hotter than ambient, especially once we've been in heavy corn a while. Air at the front screen should stay close to outside temperature the whole time." They rigged 2 simple temperature probes, one taped just inside the rotary screen where clean outside air should be entering, and one positioned as close as they could safely get to that lower gap without disassembling anything yet. They ran a control test first, driving the combine down a stretch of the farm lane at operating RPM with no header engaged, the same kind of running condition that had never once produced an overheat. Both probes read close to ambient the entire time, within a couple of degrees of each other, exactly what you'd expect from a healthy, properly sealed cooling path, with nothing unusual pulling air from the wrong place. Then they took it into the same heavy corn block that had triggered the original failure, running a full harvest pass with the header down and threshing load applied. The front screen probe stayed close to ambient the whole time, tracking outside air temperature with only a slight rise as the day warmed. The gap probe told a different story. It climbed steadily from the moment the pass began, and by the 25-minute mark, right around when the coolant temperature gauge started its familiar upward drift, that gap reading was running significantly hotter than the front screen probe, hot enough that it could only be explained by air pulled from somewhere near the engine itself rather than from outside. Roy stared at the 2 readings for a long moment. "Show me that again." They repeated it in a fresh pass, same result, same gap, same pattern. Buck happened to be driving past the field edge in his truck when they ran the second confirmation pass, and he pulled over long enough to see the 2 temperature readouts side by side for himself. He didn't say much, just studied the numbers, glanced once at Corey, and told Roy he'd hold off telling Gene to sign the radiator order until they'd finished whatever they were doing. It wasn't an apology exactly, but it was as close as Buck was likely to get to one in the middle of harvest. "If that holds under one more run," Roy said, "we're pulling that shroud apart before anybody orders a radiator." They shut the machine down, let it cool, and removed the lower shroud panel where the 2 probe readings had diverged, exposing the space behind it for the first time in what was probably several seasons. What they found matched what Corey had glimpsed with the flashlight days earlier, only worse once they could see the whole thing. A rubber and foam seal strip, designed to run the full length of the gap between the cooling stack and the surrounding shroud, had deteriorated badly on one side, crumbling away in sections and pulling loose from its channel in others. Where the seal had failed, chaff and fine dust had packed into the opening over what looked like more than a single harvest, forming a dense mat that partially blocked the front screen's normal airflow path, and worse, created a low-resistance route for the fan to pull hot air from around the engine compartment instead. The radiator core behind all of it, once they could finally see it properly through the gap, looked reasonably clean, consistent with Roy's earlier cleaning effort. It wasn't the reason the machine had been overheating. It had been trying to do its job the whole time while starved of the properly sealed airflow path it needed to actually work. "Core's still serviceable," Roy said, running his hand along the exposed radiator. "It's old, and Hollis wasn't wrong that it's flowing a little under spec for its age, but that's normal wear for a core this many seasons in. It didn't need replacing. It needed the air it was designed to get in the first place." This seal's been failing a while, probably longer than this season. Cleaning the front stack helped some, because some of what I pulled out was sitting right at the edge of this same gap, but I never got behind it because I didn't know to look. Hollis, who'd come back out once Roy called him with the readings, crouched down and looked at the crumbling seal himself, working a piece of it loose between his fingers. "Flow test I ran wasn't wrong either," Hollis said. "Radiator really was moving less coolant than spec, a little under, not catastrophically. On a healthy airflow path, that small a shortfall wouldn't have shown up as overheating at all. The system's got some margin built in for a core this age. What it didn't have margin for was fighting a fan that was half feeding itself hot air instead of pulling clean air through the core the way it was designed to. Stack those two things together, and you get exactly what we saw. Take the airflow problem away, and the core's got plenty left in it. It never really overheated on the road because there wasn't enough chaff built up in that gap yet to matter, and whatever hot air did leak in got carried off by ambient airflow around the machine at speed," Roy said, mostly working it out loud for himself as much as for anyone else. "In the field, dust and chaff kept feeding that same gap the whole time you ran, and the hotter it got up under the shroud, the more the fan pulled from there instead of the front. It wasn't the radiator losing capacity. It was the radiator never getting the air it was designed to get in the first place." Corey didn't say much back. He'd already worked out something close to that same explanation 2 nights earlier, sitting at his kitchen table, looking at the 2 temperature readings side by side. They ordered a replacement seal and baffle kit for that section of shroud, along with new fasteners for a mounting bracket that had rusted through and likely contributed to the seal pulling loose from its channel in the first place. Parts came to a little under $300. Labor to strip the chaff mat out properly, deep clean the hidden side of the cooling stack that had never been reached before, and install the new seal correctly ran the total repair to just under $900, once everything was tallied. Gene didn't say much when Roy called him with the news, other than to ask him to repeat the number twice, like he wanted to be sure he'd heard it right, compared to the $12,000 sitting folded on the hood of his truck. Buck was there when Roy laid the old seal out on the tailgate, the crumbling rubber strip, and the packed mat of chaff pulled out from behind the shroud where nobody had thought to look for 3 seasons running. He picked up a piece of it, turned it over, and set it back down without saying much, which for Buck amounted to a fairly clear concession that he'd been wrong to want the radiator order signed 2 days earlier. "I've been running combines a long time," Buck finally said, mostly to Corey. "Never once thought to look behind that panel. Wouldn't have occurred to me it mattered." "Didn't occur to me either till the road didn't add up," Corey said. "Figured something had to explain that." They ran the full test before calling it finished, because a repair wasn't proven until it held up under the exact condition that had exposed the problem in the first place. They waited for another dry, heavy stretch of corn, the kind that had triggered the worst of the overheating before, and ran the combine for a full afternoon instead of just a quick pass, header down, threshing load applied, chaff kicking up steadily behind the machine the entire time. The gap probe, still taped in place from the earlier test, held close to the front screen, reading the whole afternoon, both of them tracking near ambient with only the normal rise you'd expect as the day warmed. The coolant temperature gauge never climbed out of normal range, not at 25 minutes, not at 45, not across nearly 3 straight hours of steady harvesting in the thickest, driest block on the farm. Gene stood at the edge of that same field and watched the machine keep moving down the rows without a single stop for heat, the exact scene that 3 weeks earlier had ended with a warning light and a folded estimate for $12,000. He didn't call it finished after the first pass either. He had Roy leave the temperature probes taped in place for the rest of that day and into the next, running the machine through 2 more full afternoons in progressively drier, dustier ground as the crew worked toward the thickest stand left on the farm, the same block where the very first overheat had happened, weeks earlier. Across all of it, the coolant gauge never wandered out of normal range, and the gap probe never separated from the front screen reading by more than a couple of degrees, holding the same tight, healthy pattern the entire time. Gene pulled the machine's fuel and engine load logs off the monitor that evening, out of curiosity as much as anything, and laid them next to the notes Corey had been keeping since the first overheat weeks earlier. Fuel burn per acre across those 3 afternoons matched almost exactly what the machine had shown during the mildest, coolest stretches of the whole season, no sign of the engine laboring or losing efficiency the way it sometimes does when a cooling system is fighting itself under load. Engine load percentage held steady too, tracking cleanly with header speed and ground speed the way it should on a machine running the way it was designed to. None of those numbers proved anything on their own that the temperature gauge hadn't already shown, but seeing them lined up together, 3 full afternoons of clean data next to 3 weeks of climbing gauges and folded estimates, was the closest thing to a formal case file the whole investigation ever produced, and Gene kept a copy of it in the same folder as the Radiator estimate he'd never signed. Gene didn't order the new Radiator, and he made a point of telling people, when the story came up around town later that fall, that none of the 3 mechanics who'd worked on that machine had been wrong about what they found. The thermostat really had been sluggish, the cap really had been weak, the stack really had been dirtier than it looked from a glance, and the radiator really had been flowing under spec. What none of them had checked, because nobody had any particular reason to, was a strip of seal tucked behind a shroud panel that nobody thought to open, doing a job so unglamorous that it had no obvious way of announcing when it failed, except through a chain of secondhand symptoms that all pointed somewhere else first. A few weeks later, with harvest winding down, Roy had Corey out with him on an unrelated call, a different combine 2 farms over with a cooling complaint that sounded, on the phone at least, a lot like a straightforward radiator problem. "Before we order anything," Roy said, handing Corey a flashlight as they walked up to the machine, "show me where the air's actually going." Corey took the light without saying much, walked around to the lower edge of the shroud out of habit now, and got down to look. The owner of that second combine, standing nearby with the same kind of folded estimate in his hand that Gene had been holding 3 weeks earlier, watched the 2 of them work without fully understanding what they were checking for, only that Roy seemed to trust the kid's instinct enough to hand him the flashlight first. Back at Vantree's farms, the combine kept working through the rest of that harvest and into the next one, the temperature gauge holding steady through the driest, dustiest afternoons the season could throw at it, and nobody watching that needle sit calmly in normal range would ever guess how close the whole machine had come to a new radiator it never actually needed. Gene started having the crew pull that lower shroud panel for inspection every spring after that, a 5-minute check added to the regular preseason service, cheap insurance against a seal quietly failing again, somewhere nobody had reason to look. It cost almost nothing next to what it had nearly cost him, and it meant the next time something behaved a little strangely under load, there'd be a habit already in place of checking the hidden side of the machine before reaching for the expensive answer sitting in plain sight.